Is my voice audible?
Yes, audible. Yes, sir, it's audible.
Okay, thank you. We'll just wait for till 6:05. I think some more people are joining. Are you able to send messages in the chat? Can you once someone try to write in the chat? Okay, very good. Thank you, Shubham. Is my screen visible to everyone? Okay. So I'll start this session. I'll just maybe introduce myself. Okay, some people are still joining. So I'm Pranav. I'm a fourth year PG student at IIT Bombay. I work on machine learning and some of its application in protein bioinformatics. So I've been working in this area like on machine learning and deep learning related areas for about maybe 5 6 years now. So I have a very not a very extensive experience also, but I have some experience. So uh, so I'm one of the TAs for this course. Every week I'll be conducting this problem solving session every Tuesday 6 to 8, and I think one more TA is conducting on every Monday. and basically we will be solving some of the problems which is there in each of the weeks. So today I will be discussing week one, some problems which will like you can ask your doubts also in the session related to this particular week, and hopefully it will help you in solving that week's assignments. And so like I'm also like going through the videos every week along with you. I have not done this particular course which is offered by Pravir Kumar sir before, but I have done other courses here in my institute and before also. So, uh, so I am also getting familiar with the way he's teaching as along with you. So, so, so when you talk about deep learning, uh, pen is working. So the way it is getting popular nowadays is because of increasing data. Like you have your mobile phones, a large amount of sensors. There's huge databases of like medical records or other kind of data that is getting generated. Companies are having lots of data. Everything is getting digitized. So there is a big like data boom that is happening. Like there is YouTube, which is like a database of videos. There are other social media that is a database of user profiles, like that. And the computational power is also increasing. So with like the size of the devices is decreasing and the computational power is increasing, so you can like solve very complex things using this computational power. Like people are simulating big black holes using it. They are simulating the weather and predicting the weather using this computational power. So in this course we'll like from the very basic level to slightly advanced stage, we will go through how this happens, how you can use this data, how you can learn things from this, how you can do some tasks, how you can automate things. That is the main goal of deep learning, and we will go through the basics of how exactly it is done using some examples, solving some problems, and what is the current trend. So if, I hope I'm clear, I'm audible, right? Okay, so I'll just go through the first question. So in the first week, there was Bayesian learning, which is the Bayes theorem is one of the basic concepts in probability, very well known. So we'll just small start with a small probability problem and see how we solve this. And probability is quite relevant in machine learning because you want to say like how probably what is the probability of your prediction. It gives a confidence of how confidence score to your whatever your model is predicting. So the question says there are 52 cards. They are drawn at random. So two cards are drawn at random from these 52 cards. What is the probability of both the cards being kings? So the total number of ways in which you can draw two cards is 52c2. And we are asked what is the probability of them being kings. So in how many ways can you draw the cards such that you get two kings? So there are in a deck of 52, in a pack of cards there are four kings. So you can draw two kings out of them in four c2 ways. So this should be our answer. So you can try to compute what this value will be equal to. like 4 factorial by 2 factorial into 52 factorial 50 factorial, right? So can someone tell me what this answer will be? And 4 into 3, 2 into 51, right? Is this correct? And there is one 2 also here, right? This is 1 by 221. So this option D is the answer. Any doubts in this question? This is the number of ways you can draw a king, like two kings, and number of ways to draw two cards. So if there is no doubt in this part, I can go to the next question. Okay, I'll go to the next question. Just interrupt me if you have any doubt. So next question is asking the base formula states which of the following. So there is one correct answer. Yeah, someone is asking something. Okay, so Saki, you want me to zoom? Is it clear now? The question asks, what is the base formula statements from these four? So can someone tell me what is the formula for posterior? What would be the formula for posterior? Probability of
probability of likelihood into prior probability.
What I mean to ask is like if you have some class, say, I think the notation that sir uses is omega 1 or omega I, and it's in observation x. And then how do you define the posterior probability? It is omega I given x, right? And this omega I given x is equal to probability of x given omega I into probability of omega I by probability of x. This is basically the base formula, where this is the posterior, this is called as the likelihood. Given the class omega I, what is the likelihood of this observation? And this probability of omega is the probability of that class being observed, that is the prior. And px is the, here it is called as the evidence, that is the your observation, what is the probability of having observed this x. Okay, so a is the, a has all these in the same format. Any doubt in this? So these are some terminologies that we can familiarize ourselves with. This term is prior. Why is it called posterior? Uh, so in a way you can say like this thing is, if you see here, this prior has this pre sound, and this has a post sound. So pre means before and post is after. So you this prior is like some information that you usually know before, and using that information or that knowledge, you are trying to come up with this. So that is a post observation, you make this. So I'm guessing this is how this terminology is. I'm also not exactly, but this is what I have come to understand. This is how I assumed it for so long. This is the prior information. Yeah, yeah. Something which we want to know based on what we already know. Okay, I'll go to the next question. So it is suppose Fourier descriptor of a shape has k coefficient, and we remove last few coefficients and use only first m less than k. So there, the Fourier descriptor, oh, there is some shape and the Fourier descriptor of the shape has k coefficients. So it is, let's say this is the Fourier descriptor, and it has, or maybe I should, so this u varies from 1 to k, or you can say 0 to k minus 1. So there, that is k descriptors, and we are only taking the first m, m less than k. What will be the effect of using truncated Fourier descriptor on the reconstructed shape? So that means you are, instead of using all the terms, you will be summing it only till m. I mean, sorry, you reconstructed. If this is the signal reconstruction you are doing, sum as x. Let's take it. And then it is au times e power online class. Sorry, what was the formula? I forgot. E power j 2 pi mu x by n, or in this case it is k. So instead of summing all the k descriptors, k coefficient, you are summing over only the m. So uh, the high frequency terms you are ignoring, which is m is greater than n. Mu greater than m you are ignoring. These are high frequency, and the high frequency terms, they tell us about the finer details of the shape, and the low frequency terms, they tell us about the general shape. So if you're only using the low frequency terms, or the reconstructed shape may be something just like this. So what can be the correct option? First option is we will get a smoothed boundary version of the shape. So this seems correct now. It's visible. I smoothed version of the shape. We will get only fine details of the boundary of the shape. Full shape will be reconstructed without any loss. Low frequency component or contour will be removed from the contour of the shape. So we know low frequency is not removed, it is the high frequency which is removed. And so we won't get fine details because high frequency is removed, and we won't get and there will be loss of information because we are removing some things. And so obviously the correct answer is A. Divya, why do you feel it will be B? Because high frequency terms, they tell us the finer details, so we are removing those, so we will lose the fine details, and we will only have the general shape of the original signal. Okay, so these things are like the elementary part, like when you have some data, first thing is how do you represent the data, how do you extract useful information that then you will give to your model or whatever to learn. But whatever is there in the real world, whatever you have captured, you have to form some representation. So these are the ways of getting those representation, and you will have some constraints like only this much memory I can use, only this much with the size of my input, things like that. And it is also task dependent, like what kind of feature descriptors that you want to get from your uh, whatever your input data is. Okay, so I'll go to the next question. The plot of distance of different boundary point from the center of the shape taken at various direction is known as. So there is some shape. We take the centroid and distance from the boundary point at various directions. So, so this theta will determine the directions and we plot the distance, right? D theta, this is d theta versus theta. So we'll get some shape we will get basically. So this is known as the signature descriptor. Yeah. Okay. Okay. So this is related to the signature descriptor. The signature descriptor of an unknown shape is given in the figure. Can you identify the unknown shape? So what is this figure telling us? That whenever you're changing the angle from the centroid to the distance from the centroid to the boundary point is constant, it is not changing. Yeah. So it's a circle, like the distance to the boundary is constant, it's not changing. This is the circle. So the distance to the boundary point is constant everywhere. So it's a circle. And what will be the radius of the circle? Can someone guess? Yeah, it will be k. This k, this k it is given here. So the distance is k. Okay. So I'll go to the next question. Which of the following is a co-occurrence matrix based descriptor? So I hope you all are aware of what is a co-occurrence matrix. Or should I explain? These kinds of matrices are mostly used in uh, what to say, image processing kind of ideas. Sorry. Which of the following is a co-occurrence matrix-based descriptor? So the co-occurrence matrix is you get a matrix AP, where P is your parameter. This parameter is some L comma theta, and the entries of AP ij will be, so if you have some image with some entries which is a pixel value, let's say 0, 2, 4, 15 something, so there are entries in this matrix. This is your image. So the image will have some pixel range, let's say 0 to 15. Some grayscale image, which entries will be from 0 to 15. So what APIJ will tell you is, if I select P equal to 1, comma, I think this is the example given in the lectures also, 1 comma 45 degree, and so I look at 45 degree how many, if I is 2 and j is 3, so I say 1 4 3, so at distance 1, this distance is 1, and they are at 45 degree, so this is one occurrence, one co-occurrence. Similarly there may be somewhere here, so this is one more. So this entry will be equal to 2 in this AP matrix. So this AP matrix size will be 15 cross, sorry, 16 cross 16, because my pixel range is from 0 to 15. So I can have 16 values for I and j. So this AP is a 16 cross 16 matrix, and this gives me like the each entry will be the count. It will be the normalized count. So finally you divide by the total number of the size of the image, the total number of pixels. And in the lectures you have some of the descriptors that can be computed using this co-occurrence matrix AP was discussed, I guess. So those were entropy, uniformity. Was signature also part of? I think it can be computed using the co-occurrence matrix, because signature is the, it has the distance and the angle. What does AP mean? AP is the co-occurrence matrix. For every parameter, like whatever parameter value L and theta you take, you will have a 16 cross 16 matrix. You're saying D is also correct. Yeah, I think all are correct. Signature also you can compute, because what you want is the angle and the distance, but you may not be able to compute it using one co-occurrence matrix. I guess you will need multiple co-occurrence matrices to find the boundary distance. So this AP matrix, it will be 0 to 15, 0 to 15. So we found one entry like 2 comma 3. This entry is 2. Like that you will have to find all. This is for one particular L comma theta value, P value. Yes, yes, it is a boundary descriptor. So you can say boundary is like at boundaries you will have a change of texture. Like if you have some object at some place, there is a change of texture, so you can tell like that is the boundary. Because a signature also uses the distance and theta, so it can be computed using what to say, the co-occurrence matrix. But I think in the lectures this was not part of it, so don't worry about it. You can I mean, it depends on how you use the what you have. I can say you can maybe ignore this option, but then you can't, because all the three are there, so you can't ignore that. Because these three are definitely co-occurrence matrix based descriptors. So maybe this option should is kind of like slightly confusing, because should we include this or not? Because they are not as straightforward to compute using the matrix like co-occurrence based matrix. So what I'm saying is, in the signature descriptor also you use the distance and the angle. And your co-occurrence matrix also has that. So using that you can find the signature for your shape using via the co-occurrence matrix. But maybe I'm just thinking to what to say optimistically, or maybe too deep into it. But maybe you can just ignore this option. Maybe this option is incorrectly included in this set of options. But the others you can safely say, like it was discussed in the lecture, as you can easily compute these formulas directly from the co-occurrence matrix. Is it okay? Okay, if there are no more doubts in this part, I'll go to the next question. If the large values of gray co-occurrence matrix are concentrated around the main diagonal, then which one of the following will be true? So we have a gray co-occurrence matrix, that is, it has some pixel values, let's say from 0 to some 255. We are asking what are the properties of co-occurrence matrix. So this is the co-occurrence matrix AP for a given parameter, some L comma theta. So what it will have is this will be a 256 cross 256 matrix, and let's say these entries correspond to like 0, 1, 2 till 256, 0, 1, 2 till 256, and the like some entry, let's say this is I, this is J, then the I comma J entry tells us how many times in the original input image, whatever input image we had, did the so it in the input image you will have some pixel values. So let's say at this position it had a pixel value of I, at this position it had a pixel value of J. If these are like L distance apart and at an angle of theta, then you count it as one occurrence, one co-occurrence. So you count how many times this co-occurrence happens throughout the image, and that will be your entry here. Let's say this happened only once. This was the only occurrence. So this will be one. Okay. So the question is asking if the larger values of gray co-occurrence matrix are concentrated around the main diagonal. So this is your like the co-occurrence matrix, and this is your main diagonal. So it is saying larger values are concentrated around the main diagonal. So the values here are very high. What does it mean? Like uh, 0 co-occurs more with 0, 1 co-occurs more with 1, or values around 1, 1 co-occurs more with 0, 1, 2, something like that, and the other values are low. So the value of element difference moment will be high. What is the element difference moment formula? Summation I summation j I minus j power k c I j, right? Yeah, it should be 255. This is the element difference formula. So it is saying the value of element difference moment will be high. So this may not be the case because I and j will be very close. Whenever Cij is high, I and j difference will be small. It may be close to 0. And when Cij is less, like when Cij is close to 0, I and j difference will be high. What is the inverse element difference formula? It is Cij by I minus j power k, right? For I not equal to j. Sum over all I not equal to j. So in this case, if you see, when Cij is high, that means I and j are close, so this value is small, and Cij is high, I minus j power k is small. So 1 by I minus j power k, this will be high. So the value of inverse element difference moment will be high. This seems correct, right? So we can say that B is the right answer. Similarly, you can check for the entropy formula also. So entropy is, I guess, summation ij Cij. This is the entropy, right? So here when Cij is high, log is high. When Cij is low, log of Cij is low. So we can't really tell whether, because of it being concentrated on the diagonal, it will be what difference it will make. Oh, here it's negative. So the C, because this is the normalized value, right? So any doubt? So Cij is high only for what to say, the near the diagonal entries, but everywhere else it is low. So we have to count that also. So if you look at this thing here, Cij will be the normalized count of AP. It is what to say. Cij is APij divided by sum of APij. So Cij is in 0 to 1 range. Now, when it is 1, it is 0. And when it is 0, when it is close to 0, there is a high negative value. So, because of negative sign, it will be high positive value. So, when Cij is close to 0, minus log to Cij, it goes to infinity. And when Cij is close to 1, minus log to Cij, it goes to 0. Is it capital Cij? Small Cij, no? I mean, it's the same Cij I have used. It's the same Cij that I've used in both the places. So I hope it is clear. Like on this part, it can be difficult to say that the entropy will be low because this is going high and this is going low, and this is going high and this is going low. IED will be low at diagonals. At diagonals, uh, what will you have? At diagonals, at exactly the diagonal, you won't be including it, where the CII values are very high. At nearby the diagonals, what will happen is this value will be low because I will be close to j. So 1 by this value will be high. Okay, in the video it has some different CIJ. Maybe it must be a typing error. I'm not sure. I'll check and I'll let you know. So at near the diagonals it will be I. That is what I wanted to say. Okay. So this part clear? Yeah, you are saying it is log versus 1 by x function. Yeah, you can say it like that. It's actually negative log. But here the log value is different and here I minus j is something different. Like your x is varying in a different way than Cij. So it's not 1 by Cij and log Cij. It's 1 minus 1 by I minus j and Cij. So any doubts in this? So the maximum probability descriptor is the entry with the maximum probability or maximum, you can say, co-occurrence. Shall I go to the next question? Okay. Consider two class based minimum risk classifier. The probability of class W1 and W2 are P omega 1 and P omega 2. So this is given. So this is what you call as the prior. And Px, the probability of your observation is 0.55. And probability of x given omega 1, the likelihood is 0.75. Probability of x given omega 2. So this is the loss matrix, that is the loss of lambda 1 1 is what? The loss that you incur when the true class is 1 and you predict 1. True is 1 and predicted is 1. Lambda, I can say maybe ij is true is j and predicted is I. This is how it was defined, right? And we are asked to find the risk r alpha 2 given x. That is the risk of taking the action alpha 2 given this observation x and all these probabilities. So we just need to use the definition of, one second. Just need to use the definition. So what was the risk formula? Can someone tell me? It is basically the like the what loss you incur, right? If you are predicting 2 for a class 1 observation into probability of class 1 given x plus lambda 1 2 someone's mic is are you asking something? Hello, is someone asking something? Yeah, if you are not able to speak, then you can type in the chat also. What is that lambda 2 2? No, it should be lambda 2 2, right? Correct. Yeah, thanks. So we are taking the action 2, that is where the loss that we take the action 2 given class 1, the loss that we take the action 2 given class 2 multiplied by the respective probabilities. So is this given to us? It's not given, but we can easily compute it because this is the posterior, right? So it was x given omega 1 into probability of omega 1 divided by probability of x. So you can just tell me what this comes out to. Omega 1 is what? 0.3. Probability of x is 0.55. Omega 2 given x is equal to, so probability of omega 2 will be 1 minus probability of omega 1. And what is asked is lambda 1 1. We just need to put this values. Lambda 2 1 is what? 0.85. So you can just compute this. So you're saying 0.042. So I haven't calculated it. So others can just verify if this is the answer. So is there any doubt in this question? We just use the definition of risk, the risk of taking action alpha 2 given the observation x. And when we take that action alpha 2, it is given to us in this matrix, loss matrix, that what is the penalty that we, or what is the loss that happens when you take the action 2. I think I should have written here. I'll just change the notation here. It is action 1, or maybe when true class is 1 and you take action 1 true class j, and you take action true class j, and you take action I or alpha I, and here you're taking the action. What is the loss that happens when you take alpha to action, and the class is omega 2. So this is like the expected value of the loss given your observation, right? This is the expected loss of action alpha 2 given x. That is the expectation value. Oh, sorry, this is 0.7 you are saying. Yeah, right. So any doubts in this? So if there is no doubt in this part, then I'll go to the next question. Okay. So here what is being asked is the posterior probability distribution P omega I given x is given in the figure for two class problem omega 1 comma omega 2. For an unknown vector x1, which of the following is correct as per Bayes minimum error classifier? So we want to predict like what will be the one correct option based on the Bayes minimum error classifier. So what does the Bayes minimum error classifier do? The error of the classifier is minimum of the probability of error. Given x and given x, right? So what it does, it wants to what to say, predict the class with minimum error. So if you see in this is the point x1, and the probability of it being omega 1 is this. And is in this probability of omega 2 given x. So this probability is higher. So the base minimum error classifier will say x is in omega 2. This will be the error that you get, the probability of error. So this is minimum. Should I say x1? So this is the correct answer. So any doubt in this? So I'll go to the next question. They're asking the texture of the region provides measure of which of the following properties. So yeah, I mean these are all like in generally only we can know that smoothness, coarseness, regularity, these are like texture properties. So we can safely go with this answer. But using the what to say co-occurrence matrix, how will you find it? That also you need to be you can familiarize yourself in that aspects also. If it's smooth, then you won't find many changes in at short distances in your co-occurrence matrix, or it will be some monotonic change, something like that. If it is coarse, then it can be very arbitrary changes may be happening. Okay. So these are all the questions that I plan to discuss today. If you have any other doubts or anything, any doubt from what we discussed today that you can ask. I think most of the descriptors that we have studied, feature descriptors, they are like sort of like for image kind of data. You registered this course under PK. So I have not discussed what is there in the first assignment that you have to do it on your own. In the next week, if you have doubt from the first assignment, then that we can discuss in the next week. Can you please discuss similarity between minimum error classifier and minimum risk classifier? So in minimum risk classifier, what you can consider, like you have a two class problem. One second. Similarity between minimum risk classifier and minimum error classifier. So what basically this is about is you want to predict, you want to make your decision such that this wants to make the decision by minimizing the risk, and this wants to make its classification by minimizing the error. Okay. So both want to minimize some kind of a property of your data and your classifier. So in the error case, what you wanted was you want the minimum, like the probability of error. If you see, it was a minimum of for the two class case. So if this is the minimum one, then that means that is your error. If this is the minimum, then that is your error. The probability of error. So we'll take the decision which is the other one. If this is minimum, you take this as your decision. So that minimizes your error, right? Is less than p w2 given x, then w2 is your prediction. In the rest case, you want to minimize this risk quantity. So that is, you have been given some kind of a loss function, which in two class case, as we saw just now, there is some matrix. Now if this matrix is of this form 1 comma 1 0 comma 0, that is weird. When you're correcting your prediction and the true class is correct, you get loss of, sorry, it should be otherwise, huh? 0 0 1 comma 1. When you're predicting correctly, your loss is 0. When you're predicting incorrectly, that is true class is 2 and your prediction is 1, you get a loss of 1. Similarly, when you're predicting incorrectly, your loss is 1. When both are 2, you're getting 0 loss. So then you use your risk formula. You compute alpha 1 given x and r alpha 2 given x, and you take the class with minimum risk. Like if this is the case, then you take the action alpha 2. This action alpha 2 may simply mean predict the class w2. It depends on how you define it or what kind of task you're doing. So is this clear? So this is just an example that I have taken where lambda values I have put as 0 1. In the When it is like this, it will be similar to the error classifier. If you substitute it in your risk formula, so if you take r alpha 1 given x, it is basically lambda 1 1 probability of omega 1 given x, what to say, lambda 1 2 probability of omega 2 given x, right? Sorry, 2 1. So what you will say is this is 0 and this is 1. Sorry, I made a mistake here. If your risk is high for this, then you take this class. Yes, sir. No, sorry, this is two. No, it's correct, no? I had made a mistake here earlier. If your risk is high, then you predict the other class. So if you see here, you're getting this opposite term. Similarly, if you see R alpha 2 given x, it will come out to be probability. So this will only happen when your lambda is of this form. So if you compare your risk, it will be similar to this. In other cases, when your loss is of a different form, then it won't be the base risk minimum risk classifier won't be similar to the minimum error classifier. Within the risk, you are introducing that loss function. In machine learning, knowledge required as is machine learning knowledge required as prerequisite for deep learning courses. I mean, some familiarity with machine learning may be a good idea, but it's not strictly required. I mean, you will learn. There are many other algorithms in machine learning which won't be covered in this course. So that is one thing. But you can do without that also, I think. But some basic understanding of probability linear algebra that may be required. Probability and linear algebra. Yeah, if risk is this, then you should choose omega one here. Right? So maximum probability descriptor is just the in your co-occurrence matrix. So your co-occurrence matrix, you can consider it as a, if you normalize it, then it is like a 2D distribution, probability distribution. So whichever is the highest value, some I comma j, whichever is the highest value, that is your maximum probability descriptor. Is there any doubt? Is there any doubt from your, like, from whatever we discussed today, or in general about the course, or the week's content that you have gone through, or the way I am conducting the session? Any feedback that also you can tell? Thank you, Pranav. Okay, I'll try to provide more questions. Yeah, sure. I think this week's content was not very difficult to go through, and very basic ideas. So I'll be, like, providing this link and link to the video and everything to the NPTEL team. This video will be uploaded in YouTube like shortly within this day. So if you maybe search my name NPTEL and the course code, you will be able to find the video of the recording on YouTube. And I think the whatever I have written also, that will be shared. That link you will be made available to you. Either you will get a notification for that, or I think in the, where is that thing? Here somewhere, I think they upload here somewhere. They might upload the link to the notes, whatever I have done. Okay, so I'll wait for till 7:45 maybe. If you have no more questions, then I will close the session. think we can try to do that. I'll discuss with the NPTEL people if we can do that. Right now, they have just asked us to discuss some like solve problems. They're asking if any practical tutorial on deep learning will be there. Like you want to learn the coding part, I guess. Yeah, I'll ask the team if that can be done. Okay, thanks for joining. I'll close the session. Yeah.